Hello friends, today we'll solve the Engineering Mathematics problem of GATE 2023 Electronics and Communication paper. So this is the first question. It is saying that let v1 vector be 1 2 0 and v2 vector be 2 1 3. Okay, and the value of the coefficient alpha in the expression v1 is equal to alpha v2 plus e, which minimizes the length of the error vector e is. So first we need to find the error vector e, then we need to minimize its length. Okay, so for what value of alpha the length of this error vector is minimum. So since this is like v1 is equal to alpha v2 plus e, so e will be v1 minus alpha v2. Okay, now we put the value of v1 and v2 and then we subtract it. So 1 minus 2 alpha, 2 minus alpha and minus 3 alpha, this is our error vector. Now length of any vector is nothing but under root of all these values. So this is 1 minus 2 alpha square plus 2 minus alpha square plus minus 3 alpha square. So squaring both sides we get this thing. L length of Le square is equal to 1 minus 2 alpha square plus 2 minus alpha square plus 9 alpha square. Now we need to minimize this Le. Now Le will be minimum when Le square is also minimum. Okay, so we want Le to be minimum, so which means Le square should be minimum. So we will simply, because and to do that we first will find the critical point and then we will check for double derivative test. Okay, so dy d alpha of Le square will be equal to what? We have to differentiate it. So this is 2 1 minus alpha minus 2 alpha plus 2 2 minus alpha minus 1 plus 9 into 2 alpha and then we equate it to 0. Okay, so this is like minus 4 1 minus 2 alpha then minus 4 plus 2 alpha plus 18 alpha equal to 0. So minus 4 plus 8 alpha minus 4 plus 2 alpha plus 18 alpha equal to 0. So 28 alpha is equal to 8. So alpha equals to 2 by 7. So there is only one critical point, so this has to be minimum. So 2 by 7 is the correct answer. Or you can also check it that d square by d alpha square of Le square is nothing but 28, which is greater than 0. So definitely there is a minimum at 2 by 7. Okay, so this is the method. So this we can use that for Le to be minimum, Le square also has to be minimum. So we can apply directly the maximum minima test on this value instead of this value. Second question is like on vectors directional derivative. The rate of increase of a scalar function f equal to xyz in the direction v at the point 0 to 1 is. So basically rate of increase of a scalar field in a particular direction is nothing but directional derivative, and we know that directional derivative of a function f at a point p in the direction of a given vector v is del f at point p dot that unit vector in the direction of v. So this is the method. So first we'll find the gradient of f del f and then we'll put the value of the point p. So del f will be equal to del upon del x of this f I cap plus del upon del y of again vector scalar field f plus del upon del z of x y z k cap. So which is yz plus xz plus xy. This is what you got. Now we'll put the value, find this at point p. So we'll put x equal to 0, y equal to 2 and z equal to 1. So this will give us 2 I cap plus 0 j cap plus k cap. So now finally to find directional derivative we'll do del f at point p dot n cap, so which is 2 I cap 0 cap k cap, and since this v vector is 2 1 2, so this is 2 I cap plus 1 j cap plus 2 k cap. So unit vector will be 2 I cap plus 1 j cap plus 2 k cap under root of this all these values. So 2 square plus 1 square plus 2 square. So this is basically under root 9, which is 3. So 2 by 3 I cap plus 1 by 3 j cap plus 2 by 3 k cap. So now we simply take a dot product. So 2 into 2 by 3 is 4 by 3, 0 into 1 by 3 is 0, 0 into 2 by 3 is 0. So basically the value is 4 by 3. So this was second question. Third question is on normal complex numbers. He is saying that let w raised to power 4 is 16 days, which of the following cannot be value of 4. So since w raised to power 4 is 16j, so this we can write as 16, and j we can write it as e raised to power j pi by 2, and then we can multiply it by 1 also. Okay, so this is the trick we will use here. Now we need to find the value of w and not w raised to power 4, so we will take 1 by 4 on both sides. Okay, sorry. So w raised to power 4 times 1 by 4 will be basically 16 raised to power 1 by 4 into e raised to power j pi by 2 1 by 4, and then 1 I can write it as e raised to power j 2 pi by k. Okay, because for k is equal to 0, this is e raised to power 0 1. For k equal to 1, it is e raised to power j 2 pi by, which is 1. Then for k equal to 2, it will be e raised to power j 4 pi. So this is 1 2 pi, and then it's 4 pi, and then 6 pi, like so. So we can write it like this. Okay, so this part will also be raised to power 1 by 4. Now 16 raised to power 1 by 4 is 2. Okay, and e raised to power j pi by 2 raised to power 1 by 4 is e raised to power j pi by 8. Now here we will put k equal to 0 1 2 and 3. Okay, the k will vary here till n minus 1, so here n is 4, so we will put it as 0 1 2 3. Okay, so this is like in all of them there is 2 2 2 2. So here we also will have like for k equal to 0, k equal to 1, k equal to 2, and k equal to 3. So for k equal to 0, we simply put k equal to 0 here, or we can first simplify it like e raised to power j 2 pi by k raised to power 1 by 4 will be what? It will be e raised to power j 2 pi by k by 4, which is basically e raised to power j pi by 2 times k. Okay, so now when k is equal to 0, so this is 0, so e raised to power j is 1, so basically 2 e raised to power j pi by 8, which is option number B. Then it for k equal to 1, it will be 2 e raised to power j pi by 8 e raised to power k equal to 1 means e raised to power j pi by 2 e raised to power j pi by 2. Okay, so this is like pi by 8 plus pi by 2, which is like when multiplying both sides by 4, so this is basically 4 pi, and this is 8, both have 8, so this is 5 pi, so e raised to power j 5 pi by 8. Okay, so 2 e raised to power j 5 pi by 8, so this is also valid, this is also valid. For k equal to 2, similarly we will get this part as 2 2 will cancel, so this will be j pi, so it will be pi by 8 plus when we plus pi, and then we multiply and divide by 8 to equate the denominator, so this will be 9 pi by 8. Okay, so 9 pi by 8 is also valid. So and even if you put k equal to 3, then we will get e raised to power j, and then it will be like pi by 8 plus 3 pi by 2, so equating 4 by, so this is 12 pi by 8, so this is 13 pi by 8, which is not there, but which would also be valid. So this part will never come. Okay, so this cannot be a value of omega, so A is correct answer. Fourth question is on complex integration. Okay, Cauchy residue theorem. So here it is saying that the value of the contour integral z plus 2 z square plus 2z plus 2 dz, where the contour c is z is equal to mod z plus 1 minus 3 by 2 j equal to 1, taken the in counterclockwise direction is. So first we need to find out, we should know that z minus a plus ib equal to r if the equation of circle, then the center is a plus ib and radius is r. So converting this in standard form, it is z minus of minus 1 plus 3 by 2 j. So center of the circle is minus 1 plus 3 by 2 j, and radius is 1. So minus 1 and plus 1.5. So this is the center, minus 1 and plus 1.5. So x may minus 1 and y may 1.5. This is the center, and the radius is 1. So this part is 1, this part is 1, this part is 1, this part is 1. So this will be 0.5, this will be what? This will be 2.5. Okay, and this is the circle. Now we need to find out the poles of this function, whether both of them lie inside it or not. So singular, to find the singular point, we put dz equal to 0. Now since it is a quadratic equation, z square plus 2z plus 2, so we basically equate it to 0. So this will be minus b plus minus under root b square minus 4ac by 2a, so which is basically giving us minus 1 plus I and minus 1 minus I. So minus 1 plus I is here and minus 1 minus I is here. Okay, so the factors will be z minus of minus 1 minus j times z minus of minus 1 plus j. So this part is outside the uh, control, so this will not be counted. We will not calculate the residue here, we will calculate the residue only here. Okay, so to calculate the residue here, we will put limit z tending to minus 1 minus 1 plus j, and then we will write this factor only. So this is z minus of minus 1 plus j times z plus 2, and then this entire thing broken into its factors. So z minus of minus 1 minus j and z minus of minus 1 plus j. So these two will cancel, and then we'll put z is equal to minus 1 plus j here. So this is minus 1 plus j plus 2, and this is like minus 1 plus j, and then minus of minus 1 minus j, so this is 1 plus j. Okay, so this will be cancelled, so this is 2j, this is 1 plus j, so this is the value of residue. Now therefore the to calculate this integration, we'll use plus 2 pi I plus, because it's counterclockwise, 2 pi I times the value of residue, sum of all the residue. There is only one residue, so r1, so 2 pi I and 1 plus I upon 2i. So I say I cancel, so 2 cancel, so this is pi 1 plus I. So pi 1 plus I is, or pi 1 plus j is this thing. Okay, so we just need to calculate the residue here, and then it's done. Okay. So 3 questions are done. Fourth question is on eigenvector. It is saying that length let the set of eigenvalues and eigenvectors matrix B be lambda k and vk, where k goes from 1 to n. Okay, suppose it's an n cross n matrix. For any invertible matrix P, the set of eigenvalues and eigenvectors of the matrix A, where B is defined as P inverse AP respectively are. So B के eigenvalues lambda के V के हैं, तो A के क्या होंगे? This is what he is asking us. Okay. So here we will simply use the eigenvector equation, that for the matrix B we can write the eigenvector equation, that just like Ax is equal to lambda x, we have B dot Vk is equal to lambda k times Vk. So these are the eigenvectors, this is the eigenvalue of Vk, and these are the eigenvector of matrix B. And it is given that matrix B and matrix A are related as B is equal to P inverse AP. So basically we'll put this thing into 1, so we can get B is equal to P inverse AP, okay, times Vk is equal to lambda k Vk. Now let's try to simplify this by multiplying both sides, pre-multiply by P to remove this P inverse. So after multiplying by matrix P on both sides, what we get is this P and P will cancel, so this will be AP Vk, and here we will get P lambda k Vk. Okay, now lambda k is a eigenvalue which is a scalar, so we can take it outside, so lambda k P Vk. Okay, now you can see it is again getting the form Ax is equal to lambda kx type form. Okay, so again eigenvector equation with this thing as the eigenvector of matrix A. So we can, and this is the eigenvalue. So A has eigenvector P Vk and eigenvalue as lambda k only. So this thing is given in option number C. So option matrix A will have eigenvalue still as lambda k only, but the eigenvectors will be P Vk. Next question is this is the next question. It is on line integral. It is saying that the value of the line integral z square dz, z square dx plus 3y square dy plus 2xz dz along the straight line joining the point D, and this is okay. So here there are two ways of doing it. First, the lengthy way which we do is we can, like, since it's a 3-dimensional straight line, you can use parameterization. Okay, which is like let x minus x1 upon x2 minus x1 is equal to y minus y1 is equal to y2 minus y1, z minus z1 upon z2 minus z1 is equal to t. Okay, so now we have x1 y1 and z1 as 1 and 2. Okay, this is x1 y1 z1, this is x2 y2 z2, and then this is x2 minus x1 is 2 minus 1 3 minus 1 and so on. Okay, and all we equate them to 2, so basically we get x minus 1 is equal to t, y minus 1 is equal to t, z minus 2 is equal to minus t. Okay, and from here we can also get the x is equal to t plus 1, y is equal to 2t plus 1, and z is equal to minus t plus 1. And then from this we get dx by dt is equal to, differentiating on both sides with time, we get dx is equal to dt, dy is equal to 2 dt, and dz is equal to minus dt. Then we also need to find the value, since we are trying to convert everything in terms of t. So at x is equal to like 1, what will happen, and like that we will find all these value also, and then converting everything we get this thing, minus t plus 2 square 3 times 2t plus 1 and 2 times t plus 1 t minus 2, and then minus dt, and then so this gets pretty long. Okay, and then once we solve all these integration in terms of t, the final answer we get is 24. Or the shorter method is, if you can realize that this z square plus 3y square plus 2xz I cap, this vector is, it has curl equal to 0. Okay, so whenever if calculate that if del cross f is 0, then f can always be written as gradient of some scalar function f. So we need to find this scalar function f. So you can see that 3y square dy can be written as d of y cube. Okay, 3y square dy can be written as d of y cube, because d of y cube is nothing but 3y square. Similarly, z is coming in both the parts, so you can see it as you can write both this term as d of xz square, because this is nothing but first function into differentiation of second function plus differentiation of first function into second function, and this we are getting 2xz, and here we are getting z square. So this entire function can be simplified as like integration from p to q d of xz square plus y cube. And in such a case, what we will do is, since it is conservative, so it is part dependent, so we just, it only depends on initial and final values, so we can convert integration, and these two parts will be cancelled, and then this will be like xz square plus y cube from 0 1 2 to 2 3 1. So we just put upper value and lower value, and again we get 24. So by this method it is very easy, but by the above method, although I have shown here, but it becomes pretty tedious and long calculation. And this is another question from vector. Let x be a n cross 1 real column vector with length L is equal to under root x transpose x. The trace of the matrix P, which is equal to x transpose is. So here it is given that x vector x is n cross 1 real column vector, so let it be x1 x2 x3 and so on xn. And now the length of the vector, we know that is, we already know it is given as under root x1 square x2 square and up to xn square, and here he has also defined it as under root xt x transpose into x. So if we take this as x, this is x, so this is x transpose, so now when we multiply it, what we will get, x1 square x2 square x3 square, like that it will be. Okay, so both are same, so length of the vector we know. Now he is saying the trace of the matrix P x xt is, so this is matrix x, and therefore x transpose will be like this. So it will be n cross n matrix, so x1 square plus x1 x2 plus x1 xn, similarly x2 x1 x2 square, and like this will get. Now we just need to find the trace of it, so trace of it is nothing but x1 square plus x2 square plus x3 square plus xn square. So this is the trace, and we know the length of the vector is under root of this thing, so basically this is L square. So the trace of the matrix is nothing but L square. Last question is on double integral. and it is saying that the value of the integral x y dx dy over the region R given in the figure is dash. So this is the region R and we need to find its double integral. Now here the tricky part is that if we take vertical strip, then you can see that here it is first function and second function, but here the first and second function are changing. Even if you take horizontal strip, then it can only be moved from here to here, because after that the value of this function is changing. So basically we need to divide this region either into this part and this part. We have to divide this double integral into two parts, or if we take vertical strip, then we have to divide this integral into region 1 and region 2. Okay, so this double integral has to be divided into two parts. So let's see first of all how we will solve it using this what is it taking two horizontal strips. So for suppose like in method 1 we take two horizontal strips. So okay, so this will be like first region, this region I am taking as region 1, and this part I am taking region 2, because here the value where the strip cut first function and second is same, and here in this region the strip cut this value at y equal to minus x, and here it is cutting at y is equal to x. So now since we are taking horizontal strip, so we need x value. So here it is y is equal to x, so x is equal to y. Here it is y is equal to minus x plus 2, so x is equal to 2 minus y. Similarly here it is x is equal to y minus 2, and here it is x is equal to minus y. Okay, now we just need to like solve this. So the let this double integral be divided into region 1 and region 2. So the region 1 is like this region is the region 1, and this region is region 2. So in region 1 what will happen is it will cut the strip 1 as y is equal to minus x to y is equal to x. Okay, okay, and so first we will, since we are taking horizontal strip, we will first integrate with respect to dx. Okay, and where x will vary from minus y x is equal to vary from minus y to x is equal to y, and y is constant, so y can be taken outside, and this part will be x square by 2 from minus y to y, so which is y, and this 2 is taken outside, so this is y square minus or minus y square, so this is y square minus y square, so this part is 0, so this entire thing is 0. Similarly on this side in region 2, what you can see is we have like xy dx, where x will be from minus y minus 2 to 2 minus y minus 2, so 2 minus y. Again y is constant, I have taken outside, and it is like x square by 2 from this way. This is 2 minus y square minus of y minus 2 square. So again you can see that when I expand them I am getting 0, so this entire thing is getting 0. So both this region, this integral, this is getting 0, so final answer is 0. Or what you can do is you can take vertical strip. This is another method. So in vertical strip, again we will divide this integral into two parts over region 1 and region 2, where this is say region 1, so it will here it will strip will cut at y is equal to minus x to y is equal to x plus 2 xy dy. Okay, and x will vary from minus 1 to 0, and in this region 2 it will cut at y is equal to x to y is equal to minus x plus 2, y is equal to x to y is equal to minus x plus 2, and then xy, and then x will vary from 0. We will move this tree from 0 to 1. Okay, so now when I solve this inside integral with respect to dy, what I get is 2x plus 2x square, and when I solve this integral with respect to dy, I get 2x minus 2x square. Okay, and so this is like 2 can be taken outside, x is equal to minus 1 to 0 dx. Okay, so this I am getting as finally 2 by 3 minus 1, and this plus sign is always there. Okay, and when similarly I solve this thing, I am getting finally as 2 by 2 minus 1 by 3. So finally what I am getting is 2 by 3 minus 1, okay, plus 1 minus 2 by 3. So 1 1 cancel, 2 by 2 by 3 cancel, again final answer is 0. So here getting 0 is like not easily seen, so we need to solve till the end to get the 0. But when we take horizontal strip, luckily in exam, then you can see that clearly we are saying that we are getting 0, although integration in both the parts is same only. Okay, so this is like method 1. This is like method 1 of doing it, but in both the cases you need to take the 2 strips, and this is the method 2. Okay, you can see it here. Okay, so these were all the problems.